Hello, welcome to this demo video. We're going to be looking today at using chromedriver and selenium module to do some web scraping. And so we're going to go over why you'd want to use this approach for scraping a website. We're going to go through the different steps of getting set up, you know, installing these two components. We're going to do a real example where we use these two components to scrape a kind of a complicated website. So we're going to go over how to, to load the site in a chromedriver browser, how to navigate and control it using a JavaScript commands being sent to it, and then we're going to use Beautiful Soup to parse out the HTML of the site. So the kind of first question is why you'd want to use these two these two components to do web scraping. Where if you've seen the previous web scraping video, we were just using request modules to basically ask the web server to send us an HTML page that is created, and then using Beautiful Soup to parse it and pull out whatever we want. So that approach works pretty well for a lot of web pages that are fairly straightforward in how they work. And so, for example, this URL at the bottom here, oftentimes you'll see in these URLs, you're sending parameters to the web server to tell it what you want it to do, right? And so in our imaginary website here, we're asking this server to send us, page 2 of the collection or whatever that is, right? So oftentimes for a lot of websites, you'll see these parameters being passed in the URL and these URL query parameters. Sometimes it's a little more complicated as like a post form data or post parameters, but usually it's pretty straightforward on how the site works, right? You're constructing a query, you're sending it to the server. The server uses those query parameters to build, talking to a database or something, build a response in HTML and sends it back to you. And so these sort of straightforward HTTP interactions can be done, in many different ways. The browser is one way of doing it, but also you could replicate this behavior on the command line using curl, or you can use Python using the request modules that we've been doing in our lectures to talk to a server and get HTML out of it. So that works great for a lot of servers, and if you're able to do that, that's the kind of preferred way because it's a lot simpler, right? You're basically mimicking these HTTP commands via requests, and the server doesn't care, that it's the request module making these requests. It just, is going to send you HTML, and you can parse it however you want. So a lot of servers don't, work like that way, but some servers are a little bit more complicated in how they behave and just, how they're set up to operate. So the way that a web server can work is, ranges greatly. But in the example that we're going to do today, this is kind of one of the complicated situations or complicated setups for a server that might require actually using a real browser to talk to it and to interact with it. So for example, if the web server is very kind of session based, then you're going to run into problems when trying to request certain pieces of information from it. And so by this diagram, you can see, your browser. This is like your Chrome or Firefox or something, and cookies is like a little piece of data that's stored on your browser, and it's sent along with every request you make to the web server. And so in this case, your browser has a unique cookie on it, and the web server is storing that cookie with all of these parameters in a database or on the server side somewhere, right? And so basically every time you make a request, the web server has all your information in the session, and you're not passing, send me page 2 via the URL. It has that information in the session, and it's really kind of just set in various ways via these requests. And so this kind of setup is difficult to use request module because you would have to replicate every little aspect of this interaction. So you have to replicate the cookie, you have to replicate sending different types of commands to modify that cookie. And it really is complicated. And so instead of kind of trying to reverse engineer every single aspect of this interaction, if you use a real browser, it kind of just does all these things seamlessly, and the website knows how to interact with it. So instead of trying to kind of fool the website into sending you HTML based on your specific request, you can just use a real browser that talks to the website, and it just behaves as it would if you're using it manually. And so in these situations, and this isn't the only situation where you'd want to use it, but basically this is the same idea where it's a very complicated kind of interaction, and trying to replicate every single little detail of that interaction is just a lot of kind of work, and there's a lot of errors you can make, and it's really based on how the server is set up, so you need to know exactly the name of all the variables and all these little details that you need to send. It's much easier in these situations to just use a real browser, at, like a person was using it, to send these requests to the server and get data back via the real browser. So the problem with this, though, is that we need some way of programmatically doing this, right? So if you're working with a web browser, yeah, and you're browsing a page, you're clicking on stuff, that's, the normal use of a website, but we can't do that for every, if we want to use some sort of automated programmatically way of interacting and web scraping many pages, we need some way to kind of connect to a real web browser and allow our Python script to talk to it and get data back through it. So that's where these two components are coming in. The Chrome driver is basically a little local server that lets you control a real browser, in this case Chrome, programmatically. And then Selenium is a Python module, like Beautiful Soup, like requests, that can interact with this Chrome driver server. And so with these two things, you can actually write Python scripts that talk to a real web browser and make it do certain things and interact via Python code. So if you kind of think of that in those terms, it's a really powerful possibility of controlling a browser via Python to do whatever you want. So the first step here is that you have to have Chrome installed. So, if you're kind of like a Firefox person, you just have to download Chrome and install it on your operating system. The next step is to get the Chrome driver from the Chromium site, and this is basically just a binary file you download. And so the thing you want to be aware of is what version you download of the Chrome driver. And so if in Chrome, if you go up to your settings or about, you should see what version you're working with here. So I'm on version 99 here. And so if you are going to download the Chrome driver, you just want to make sure you're downloading the right version for your Chrome version, right? So I'd want to download the version 99 because I'm using Chrome version 99. So you just download that, and it'll give you options for your different operating systems. So there's one for each operating system. I'm on a Mac, an older Mac, so that's fine. All right, so that's the first step. We then have the next step is installing Selenium via pip and configuring it. So we'll do that. All right, so I'm going to open up a new terminal window here, and I'm going to go to my downloads directory, and I'm going to make a new directory here just for this project. And I'm going to change directory into that directory. And so the first thing we're going to do is we want to extract the Chrome driver that we just downloaded. So I'm just going to do this in the GUI. I'm going to open up the site I'm in, and I'm going to drag over that file, that zip file we just downloaded. So I'm just going to extract this, and you'll have like a binary file that's left over, and you can delete the zip file if you want. So the problem, depending on what system you're on, this can behave differently. If you try to run this from Selenium just without authorizing it to run first, you'll get like a security error. So what you can do is just right-click on it here. If you're in, Mac, if you're on Windows, it might be a little different. But you just want to open it, and so you get permission to actually run it. And this will pop up and say like, "Are you sure you want to do this?" And you'll say, "Okay." So now it's like kind of put on the allow list for the system to allow this software to run. So we can just close that after it's done and terminate it. All right, so now that that is installed, what we want to do next is install the Selenium module. So what we're simply going to do is use our pip installer to install the Selenium module. And then, I'm installing it globally here. And so it's installed, and the next thing we can do is make our test script here that we're going to work with. So before we do that, let's look at the site that we're going to be practicing with here. And so this site is you can tell from the file, the URL name, it's like a Microsoft server site. I can kind of give you an example of what I mean, how the site is a little bit complicated. So if you have your developer tools open here, if you go to File, or if you go to Options, you go to More Tools, then Developer Tools, this will open up down here. And so this really kind of gives you a insight into how what the website's doing and the different requests it's making and the JavaScript consoles and all that. So if I press this, I'm on this one page and say I want to scrape this page, right? I want to scrape all of these resources on this page, all these different items here. And so that means I would probably need to go through different, all 1,400 of these pages and pull out information, right? And so this is obviously the first page. So if I wanted to go to the second page, I click this in the website, right? And as the second page loads, you can see this is the second page. This is different content, but you'll notice in the URL at top here, it didn't change anything in the parameters, right? It didn't say, okay, now page 2 or anything like that. It just is the same URL, right? And so if you dig into the network tab here and you look at the different requests it's making, you can see that this is the main page request, and you can see all the different headers that it's sending and stuff like that. But the main thing that we're interested in is this payload. So this is what the browser submitted to the server to get to the second page of the requests of the collection here. And so you can see there's all these payload variables, and this one is this huge kind of hashed value, and then it has all these kind of cryptic variables and stuff like that. So if you were going to recreate this via request module to kind of do it via Python, you would need to know how to recreate these giant variables and send them to the server to get the data that you want back. And so this is actually, it's difficult because you don't know how the server works and what even is this variable being sent and how does it create it and all these things. Who knows if you can change the page number in here or if you need to change it in one of these ones, and do they need to reflect it in here? It's just, a lot of kind of reverse engineering you'd have to do to figure out how this thing actually works and how it's actually changing the page contents, right? And so you can avoid all that because we don't need to recreate or reverse engineer what pieces of information we need to send to the server if we just do it through the web browser, right? If we could just have the web browser click this button, 1,400 times and pull the data out, then we don't have to worry about all that, creating the headers and creating the correct parameters and all that. It's just doing it for us in the web browser automatically. So that's kind of the core of this problem, right? And so what we want to do is basically use these chromedriver and use Selenium to load this web page up in a browser that we can control programmatically, and then use Selenium to either click this thing or change the page number, and then pull out the data using Selenium. So that's kind of the goal for this example. So to get started, we're going to, of course, make a script, right? So let's edit a new script. We'll call it test or something like that. I already have a test. So let's do test scrape. All right. So what we're going to do is we need to import the tools that we're going to use, right, for this project. And the first one of those is being the Selenium module that we just installed, right? And so for that module, we're going to import Selenium. I'm sorry, from Selenium, we're going to import the what we call the WebDriver, which is basically the interface to the chromedriver. And so, I spelled that wrong. So what we have here is the Selenium is the module, right, and we're importing the WebDriver kind of piece of it. And so before we get started, we need to configure the WebDriver component to look at our chromedriver that we just downloaded, right? So this is in the same directory here. Here's our chromedriver. Let me save this. Here's our Chrome driver, and here is our test script, right? So what we need to do is tell uh, the WebDriver that we wanted to use this Chrome driver binary to create a browser. And so the way we do that is pretty straightforward. We just basically create a new variable. We can call it driver. We can call it whatever we want. And we're going to use the WebDriver. I'm sorry, this is WebDriver, not WebDrive. WebDriver, and we're going to say .chrome. And we just have to tell it the executable path. And the executable path goes in here. And so, if you had downloaded this Chrome driver binary somewhere else on your computer, you'd have to give a full path to it. But because the Chrome driver binary and the script are in the same directory, we can just simply say the file name, which is Chrome driver. So now that we have that, it basically is kind of connecting our Selenium programming tool to the Chrome driver browser tool. And so now we can use Selenium to spin up a web browser that we can control via this Python script. So to get started, we need to basically tell it to get something, right? So we're going to say driver dot get and then a web page. Let's just use like the Google homepage just as a quick example here. So if we ran this, we should get to see a new browser opened up and kind of displayed on our desktop here. So let's try to run this script, see what happens. All right, right? So it opened up and it went to the website that we asked it to, right? So if I close this and I change this to, something else, let's see, if we change this to, like CNN or something, whatever, you can run it and it will do the same thing, right? So what is happening, you can see that this is, it says up here, Chrome is being controlled by automated test software, right? So this is not my user ID up here. This is like a brand new browser in its own session, completely disconnected from my Chrome session that I have, running in the background. You can see it's just basically a new browser, and it's being connected to our script via the Chrome driver. So what we can do is, now we have control basically of this browser via this Python script. And so what we could do is all sorts of stuff. But in our case, what we want to do is basically navigate this interface, right? So if we think again what we want to do, we want to maybe click on this button a lot or change the page and try to get to the end of the pages so we can pull out the information for each one, right? So it'd probably be nice too to make this bigger, right? So that we have more pages or more items per page. So we don't have to do 1400 times. We can do, however many less it is if we do have 24 per page. And then we maybe want to change the page number or click this button to move to the next one. So the first thing we're going to do is change out this to our real website. And if we ran that, we would it would open up, and it would load that page, and we would see it. But what we want to do is be able to modify the stuff on the page. And this is where it gets really kind of interesting using this Chrome driver, because what you can do is you can send commands to the Chrome driver web browser with JavaScript commands to it as you would if you were on the console. So let me show you what that means. So for example, say we wanted to change this records per page from 6 to 24, right? Well, you can do that manually here, but you can also do that via JavaScript. And so, if you're not familiar with JavaScript, it's a big topic, but we're just going to do some very simple JavaScript commands that, don't require a lot of kind of knowledge of how to use JavaScript. But one of the main things you need to do, similar to just kind of normal web scraping, is identifying the piece of the page that you want to interact with, right? So we want to interact with this drop down here and change it to 24. So I'm going to inspect it. And what I can see is that this is the select element that has the options in it here. You can see all the options here. And so I want to find a way to uniquely be able to reference this element in my script. And so fortunately for us, there is an ID. It's given an ID here, and this is the ID that is assigned. So we could theoretically reference this piece of this element, this select element, using this ID. And so we can practice this in our console. And so, you'd have to look this up, but to get a element in JavaScript, you say document get element by something. In this case, we're going to get it by ID, and then you just pass the ID as a string there. And so if I ran that, it returns what it got, and it returned this, a reference to the element. So we know that we're referencing the right thing from this code here. And so what we can do is actually, for most form elements, there's a value property built in. And what you can do is actually just set the value to something directly. So we know we want to change it from whatever it is, 6 to 24, right? So you can just set it equal to 24. And you can see that it flipped, right? So in this one line of JavaScript, I'm changing the records per page from 24. So, but you notice that nothing happened on the page. It didn't really refresh, right? Because it just simply changed the value. So what we need to do is figure out, like, okay, what's happening when you change this input value that's actually triggering the page to reload with 24 elements, right? And so if you look at this, if you inspect this element in your tools here, there's the different styles, and this is the CSS stuff, but then there's this event listener tab. And you can see all the events that are assigned to this particular element. And we have a couple types of events assigned to it, but it looks like the big one is change. And so basically, we could click through to here to see what happens when you change. And this is like a very old site, and it has some JavaScript thing on change. It does some very complicated JavaScript things to tell the server to change that complicated cookie so that it changes the number of items per page. So we don't need to worry about that. All we need to worry about is that we know that we can change the value here, but then we need some way to trigger this on change event. So we need to tell it that this number has changed, and so it runs this complicated code for us, and it does all the stuff for us that we want it to do. So what we can do is there's actually a way of triggering a change event using JavaScript. And how we do that is by issuing uh, what's called a dispatch event. And so to do that, we need to still reference the element that we want. So here is we set it to 24. You could set it back to 6 again, back to 24. And then what we want to do is trigger a change event. So to do that in JavaScript, you say dispatch event, and then you have to make a new event and ask it to change. So we're going to make a new change event, and then once that change event is triggered, it would be like if I change this manually, and it will start doing stuff. So to trigger this event, we're going to just reuse the same code that we were doing to select the element, right? Because we still need to select the element to tell it that we want it to change. And we're going to say dispatch event. And inside of these parentheses, we have to basically create a new event. So we'll say new event. And inside of here, we say what type of event we want to create. It's a change event. And so this will mimic like if I had clicked this manually and changed it manually, but we didn't do it manually, right? We changed it via this JavaScript line, and then we kicked off the event via this change event. So if I run this, we can start to see that the page is changing, right? It's loading here. And so let's wait for it to load. And so after it loaded, we can now see that there's 24 items on here. And so now, we'd have to do this much fewer times here. All right. So you might be saying, okay, that's interesting. You're changing JavaScript in the browser here to do stuff, but that doesn't really help us. But what's interesting with this Selenium is whatever you do in the browser via this JavaScript commands, you can actually do in the script, in your script as well, your Python script. So let's go back to our Python script, and once we have loaded the once we've loaded the page here, it'll just be sitting there like we saw, right? And then we want to do these commands. We want to send it these JavaScript commands to change the page number from 6 to 24. And so to do that, we can define our JavaScript commands. We could do this in a separate variable. And in Python, if you do triple quotation marks, it is like a string, but you're allowed to have line breaks in it. Normally with a string like this, you can't have line breaks across multiple multiple lines for that string. But if you do a triple quotation mark, you're allowed to do that. And so we're going to build this JavaScript command, and basically it's just going to be the same command that we did before in the console. So we can just copy this exactly and paste it in here. And so this is kind of weird because we're running JavaScript commands inside the basically Python script. So we're going to put these two commands. I'm just going to terminate them with a colon just to make sure it knows that it's the end of the command in JavaScript notation. All right, so now we have this command set up, and the driver, WebDriver, has a built-in method called execute script. And you basically just pass it a string of the JavaScript you want it to run. And so we're just going to say that. And so if we run this, we should theoretically see it open up a new window and then change it from 6 results per page to 24, and then trigger that change event so then it reloads and it's actually on 24 items per page. So let's run this and see if it works. All right, so it was pretty quick, but you can see that this changed to 24, and then the site started loading again, so we'll wait for it to finish loading. And so now it finished loading, and you can see that it actually now loads 24 items per page. And so none of this is in the URL or anything like that. This is not being communicated via the URL, so you wouldn't be able to replicate this via a request. This is in the cookies. This is in those complicated variables being passed to the server. And so we don't need to worry about all that because we're just doing it like we're doing it manually. And we're just kind of pretending, just like kind of controlling the browser like we're doing it manually, but it's actually programmatically. All right, so now that we've changed the 24 items per page, now we need to do this much less, right? Because there is now 356 items or 356 pages versus 1400. And the next step we want to do is find a way of looping 356 times, either press this or change this value here. And so if we think about this, there's a potential that this could be interrupted, right? There's potential that it's not going to work perfectly 356 times in a row, right? And so if we're relying on clicking this button 356 times, that means it'd have to work perfectly 356 times in a row, all the way to the end. If it broke halfway through, then there's no way to pick up, halfway through. And so what we can do is, instead of saying clicking this button, let's just change this value here. So to replicate this this manually. So let's do this. If you're a person changing this, you change this to a certain page, and then you hit enter, right? And we can see it's starting to load. All right, so loaded to page 99, right? So now we're on 99 of 363.56, and it's a different content, right? So instead of clicking this button many times, 300 sometimes, we can just simply maybe change this to one of the values and then hit enter. Or programmatically, we basically change the value of this input and then hit enter programmatically via JavaScript. So let's try to do that. So that, of course, we need to be able to do this in the console first before we can translate it to our Selenium script. So first we need to identify the element we want to change. And so we know that this is the input. It's highlighted here. And again, it has this ID defined in the HTML. So we can kind of reuse the same type of code that we were doing before, but use a different ID. So let's delete this one. So we're going to say document get element by ID, and now use this new ID that we found for this input here for the page number. And we can make sure that's the right one. It's referenced correctly. And so this is the input element too. So in HTML, it has a value. So you can simply hard code the value to whatever you want, right? So we could change this to 200, and we'll just change it there. So like the changing records per page, this is not enough just to changing it, the value in the HTML. We actually have to trigger like a key press. So we have to like pretend like we hit enter on it. And so, this is not necessary, but just to show you can do the same thing we did before where you look at the event listeners, you can see that there's a key press event for it and that it is looking for a certain thing here. If we look for the JavaScript here, it says if the key on the key press event, if the key code is 13, and 13 means enter key. So do this complicated JavaScript that we don't understand and we don't care about. So what we can do now is we need to create an event that is basically mimicking me pressing the enter key here. And so we can do that in the same way that we did the other event, but we just have to change the type of event that we're passing to it. So let's load up that other event that we did before. So all we're going to do is change the ID to the correct ID, right? Back to this one. And we're not going to dispatch just a generic event. We're actually going to dispatch a keyboard event. And so this keyboard event, there's actually a number of different types of keyboard events that could happen. There's like key down, key up, and key press. So we know from looking at the elements that this is expecting a key press event. And so we're going to change this to key press. And the second parameter that you pass to this keyboard event is a bunch of flags. But basically, you can tell what key, what it's looking for. And so, this is not, this is a little bit kind of based on knowing about HTML and JavaScript. But the way that this website is doing this is a very old website, and so it's looking for this key code event. That's not usually how it's done anymore. Usually there's it's just like it's this key and there's a string like enter or there you can look this up too. To see what different types of events can happen. So you can pass it the key, you can pass it the code, and you can mimic things like is the control key pressed, is the shift key pressed, is the alt key pressed, all this stuff, right? And then at the bottom here, you can also pass it the key code, which is what we're looking for, and some other stuff. So just be safe, we're going to pass it a key, the code, and then the key code. And so this is all kind of JavaScript stuff, but so we're going to pass it the key, which is enter. We're going to pass it the code, which is also enter. But we're also going to pass it the key code, which is going to be 13. And we know from looking at the source code of this page, that's what it's looking for. So we should be able to run this command, and it should switch this. It's automatic. We've already done this part where it switches to 200, but this code should trigger a key press event, a key down on the enter key, a key press for the enter key in this input field. And so that should trigger it to load the next, or take this value and load that page. All right, so loaded the page 200, and so we can see that that works, right? So our code is working. We can manually change this to something, and then we can um, mimic a key press, a key press, enter key press event for it. So if you think about what we needed to get working, we kind of have this set up, right? So it's going to open the page in the browser. It's going to set this to 24. Then it's going to loop 356 times and change this page to for each iteration to the next page and press enter, right? So let's go back, let's copy this code and implement that in our script. So we need some way to loop, and so one way of doing this, of course, is with a for loop, and we can say, we can call this page in, and then we need some way to count from 1 to 356, right? And so we can use the range function here. So we can say start at 1 and go to 356. It's inclusive, so we actually have to go to 357. So it will stop when it hits 357 and it won't actually loop. It will just get to 356. All right. So what we want to do in each loop here is that JavaScript commands that we've been doing. So let's overwrite this variable again. We'll use it again. We'll use our new JavaScript commands. And so let's go back and copy this. And so we'll copy this one changes the value. And so we'll change the value from, we need to change it from, we don't want to hard code it to 200 though, right? We want to change it to whatever page we're on in the loop. So we can actually turn this from a multi-line string to a multi-line template string by adding an F here. And then this allows us to drop in variables inside of it. So we could take the page variable and plunk it in there, right? And then we'll add a semicolon at the end just to make sure it knows that's the end of the command. And then we need to simulate the enter press, the key press on the enter key. And so we'll send this command here. So you notice here, it's kind of, this is a problem you could have when you're mixing different programming languages together, right? Because we're basically mixing JavaScript inside of this string, this Python string, and you can see that it's kind of not happy about this, right? Like it's not all green here, so it doesn't look like a big string. It's because, of course, we're using quotation marks here as well in our JavaScript code. So, JavaScript doesn't care if you use double quotes or single quotes, so we probably want to change those to single quotes. Oh, but that's not the problem. The problem is we're using these curly brackets where it's thinking we want to plop in a variable like here, right? So to actually use curly brackets, not use a variable, we just have to escape these. So you can use double curly brackets, and so that will instead of looking like it's trying to insert a variable, it will just insert a literal curly bracket there and not try to insert a variable. So, as you can see, this is a little bit complicated, trying to add JavaScript within JavaScript or within Python. You could do this different ways too. It doesn't necessarily have to be like using these fancy multi-line template strings. Another simpler way to do this would be to say JavaScript equals an empty string. Then you could say it equals itself plus this command, right? Put this in a string. And then add the page number you want to the end of it, right? And then add the colon. The problem with this is that we need to turn this into a string because, if you're trying to add a string to a number, it would error out. So then you could do the next line too, right? and add this command in. So, there's a lot of ways of doing this. If this one is a little too bit kind of fuzzy or why it doesn't really make sense to you. Um, but so we're going to be sending this command, 356 times. And we're going to have to do more work about this, but we just want to see if this works, right? So we want to make sure that it's um, actually like triggering these page changes and that we can watch it increment up page to page, right? So let's run this and see if it works. All right, so loaded, and you can see it changes the records per page. That's the first command. So it's loading the 24 records per page. And now it is going to run the next step of commands. Oh, but it looks like it didn't work, right? So we got a lot of doing page 111111111. So something's up here. We can also look in the console of this new window and see if there's any command, any sort of error messages relating to what we did. And this is just error message relating to the page by default. So it's just printed doing page 111 over and over again. So let's see why it would do that. Oh, okay. Yeah. So you actually have to run the command, right? Not just create it. All right. So we're going to run the command for real this time. So I'm going to close this and run it again. And of course, you don't need to leave. This doesn't need to be focused or something like this, right? It doesn't matter. It's not like we're sending keystrokes to it. We're doing this programmatically, so this could actually be on top of it. It doesn't matter where the window is on your system. It's just running these commands to it. All right, so it loaded the page and it changed this to 24, and it is executing this. Okay, I see. This might be interesting. So it did change it. So I'm curious if it like queues up the commands, but it looks like it did change it to 24 pages and it's still loading again. So we'll see if it goes to what page it does next. All right, so it's loading we're on page 2 now. So it should go to the next page, page 3. Or this changed this to page 2 and now it's loading. So then it changed this to page 3 and then it's loading. So it looks like it's working. So there is some repetition, right? Because page 1 is automatically there and we're loading page 1 again. So it's a little bit duplicative there. But it looks like it's working. This is not working here. We're just printing page 111 over and over again. So let's close the script, break it, and see why it's we hard coded 1 there for some reason. Let's change that to the variable so it prints the actual page numbers on. But it looks like it works, right? It's loading the page and it is changing the input value and then hitting enter or simulating hitting enter, right? So what we can do now is, and I should add, you can do all sorts of simulated events here, right? You can click on stuff, you can create mouse events, you can just locate items and use the click method in JavaScript to pretend like you're clicking on it via the JavaScript. You can do all sorts of stuff like that. All right, so this is working well, right? We're navigating between the pages. And so now we're still not even to the point though where we're pulling out data, right? So once the page is loaded, we need to actually get access to the HTML. And so you can access the HTML pretty much anytime you want, via this elements panel in the console. But with Selenium, you can actually get the HTML of the page at the time that you run the command. And so we want to do that, right? We want to pull down the HTML of this page before we go to the next page. And so to do that in Selenium, it's pretty straightforward. So we want to wait for this command to execute, and then we're going to get the source code. And so you can do that by saying driver dot page source. And so now this returns the current HTML of the page, and we're storing it here in this variable. And so what we could do is let's save the HTML for this page somewhere. So we'll make a directory here. We'll make a new directory called HTML. So now we have our script, our Chrome driver, and our empty directory. And so what we can simply do is open a text file, or in this case, a HTML file. We'll call it source, and we'll give it the page that we're currently on, .html, for write mode as out file, and we'll just say out file.write, and we'll write out the source code. And so now this should run, and for each page it should write the source code, the current source code, out to the file in that directory. Oh, we have to tell it what directory, right? HTML. Otherwise that would have written it in the same directory as the script. Alright, so let's run this again and see if we get some data back. And I'll kind of fast forward here. Alright, so it ran a number of times here. And what we want to do is just make sure that we're seeing different results here and what we were expecting to see. So for example, what I would do is open up, this is on page 7, or it's loading page 7 now. So now it's on page 7, it's loading page 8 now. So I would open up the page 7 source code and just make sure I can find some of these things on here, right? So common name, sugar, maple, right? Okay, yeah, there it is. Let me check another one. It might be difficult because, oh, now we're on 8, so I'd have to go back to page 8. Look for this word, right? It's there. So, things might be broken up into different elements, into differently, so you'd have to be careful that you're looking for the right thing, but you can just double check that the data that you're expecting to be there is actually there. And it looks like it is. All right, so what would happen though? So we're on page, let's see, we're on page 10 here. So what would happen though if something happens, the internet goes down, something breaks, right? And this really messes up the script. So it stops there, right? What we can do is, since we're saving each file, so notice we haven't pulled out the data yet, right? We're just saving the HTML files to this directory. So what we can do though is this is a good approach because we don't exactly know what we want to pull out. So if we try to pull out the data in that one script, then maybe, in a week we'd say like, oh, I really wish I would have pulled out this other piece of data. But if we're saving the HTML itself, then we'd have no problems going back and changing that, right? It's not like we have to do this hard work of loading the 356 pages again and again. We just have to do it once. We have the HTML saved locally, and we can use that to work off of. The other thing we can do with it, though, is that if this file exists, then we know that we already did that page, right? So we don't need to do that page again. And so what we can do is add some code to our script using the glob module. And so the glob module is a way of getting lists of files that exist on the hard drive. And so we could say, okay, glob, we can say all HTML, we'll say all existing HTML files. And we can say glob.glob, and I can say, I want you to look in the HTML directory for all the HTML files. And so this will return, and we can turn it into a list. And so this will return a list of all the HTML files in the HTML directory. So let's comment this out and just see if that works. To see what we get, if we get what we expected. Right? So it returned all the HTML files, and notice that includes the prefix, the HTML directory prefix there. So it returned all of them. So now we know which files exist, and so we could check to see if that file already exists, and if it does, skip that page, right? So what we can do here is, so we're kind of like hard coding the file name here. We could move that up here and say file name and set it as a variable and make sure we put this back here. And so now we have the file name for the current file. So if that file name is inside of this list of files that already exists, then we know we already did that one on a previous run. So we could check that with the if statement and say if the file name is in, if the file name is in the all existing files, then just continue to the next one. And we should probably move this print statement up here. And we could add another print statement here saying skipping page and then this page. So if it skips, we should put this back here actually, because then it won't ever get to here and we'll just say skipping page. So if this works, then we should cut down on the first 8 pages, right? Because we only have 8 done so far, or 10 pages, sorry. But we should skip those first 10 ones after it does that initial switch from 6 results to 24, right? So let's give it a shot and see if it works. All right, so it loaded and it's changing to the 24 pages here, but it's kind of queuing up those commands. But you can see that it skipped the first 10 pages, and so we should see this going automatically to page 11 on the next reload. Yeah, so this is changes to page 11. So it's loading page 11 now. It hasn't gotten there yet, so the file doesn't exist. But then it should, load page 11, and then we will have page 12 loading. All right, so this, you'd have to run this for a while, and it would go through and pull down all the pages. I won't run it for all of them, but I'll run it for a decent amount, and then we can move on to the next step, is actually pulling data out of this. But at this point, we're pretty much done with Selenium and chromedriver because we have pulled out all the HTML from the browser using Selenium and chromedriver. So like I said earlier, you can use Selenium to send all sorts of commands to the browser. If you think of it this way, whatever you can do in the web browser, you can do via this programming language, and it's just a matter of figuring out what commands you need to send or how you're going to do it. But pretty much anything is possible that you could do manually, you can do via sending commands, which is super powerful. All right, so we'll let this run a little bit, and then we'll do the next step. All right, so it finished running. Well, I ran it for a while, and it did actually error out at some point. The internet connection dropped, or the website stopped responding, or something. But we got to 285 pages, and so you can see why it would be good to have that ability to recover from whatever page number you kind of ended on. So if I really wanted to get the rest of them right, I could just run this again, and it would pick up at page 285 or 286 and keep going. But now we're kind of on to the next step here, where we're going to want to do something with this data, right? And so we can, we've basically been using chromedriver and Selenium as a way to get access to the HTML, right? Where we can do that via request. And so now that we have access, we can just use the same methodologies that we use to extract data from HTML if we were using requests, right? We can just use Beautiful Soup to do this. And so let's make a new script that, right, so here's our chromedriver HTML and our test script. Let's make a new script that does that. So we'll make a new one called extract py or something like that. And in this script, what we're going to do is work with the files that we've downloaded from the chromedriver and selenium process. And so what we need to do is, like we did in the other script, we need to be able to know what files to work with. And so we can use the glob module to do that. And we're also going to use Beautiful Soup. We know we're going to use that to extract data from the HTML. So we're just going to import that. Oh, I always get this backwards. All right, so we have those, and so we're going to use glob to get a list of all those files. So we're going to say all files is glob.glob, and look in the HTML directory. Um, if I had did this HTML, this would have looked at the root of the entire hard drive, which we don't want. We just want the HTML directory, and then anything in there that's the HTML file. And so we're going to turn this into a list. And we can say, okay, for file name in all files, and let's just print the file name and make sure it's working. All right, so there's all the file names. So what we need to do is load this data for each file and pull in the HTML and then use Beautiful Soup to parse it, right? And so what we can do is use the file name that we have, and we'll say with open, and we'll give it the file name. It's as read as in file, and then we can say HTML equals in file dot read. And we can print out the HTML. Let's make sure this is working for each file. Let's see. We can see a lot of HTML. All right, so we know that's working. Next step is to initiate Beautiful Soup so we can parse it. And so we do that by saying Beautiful Soup, or we'll make a variable soup equals Beautiful Soup dot, we just tell what we want it to parse. And so we want it to parse the HTML file that we brought in. And we can give it a hint of what type of format it's in by saying HTML parser. Otherwise, it will just complain a little bit about that. So we can run this again, just make sure it works. And it's just running. It's kind of running for each one. All right, so we can stop this and continue on. All right, so now this is like any other step in this process where you have to identify how we're going to actually extract the data from the pages. And so we can open up the one of these HTML pages that we downloaded. And right, this is just the HTML file, so there's no CSS included here, so that's why it looks kind of funny. And we can see some of these images work, and we could figure that out by looking at the images that do work, and we can see this has a full URL to an image, whereas images that don't work have a relative URL. So since I opened this file on my computer, the HTML file on my computer in the browser, it's, this doesn't have the rest of the URL to know where to load this file, so it doesn't work. But we need to decide how our approach to pulling out this data, and just kind of giving it a glance, we can see that there can usually be like 4 pieces of data. Sometimes there's 5 synonyms. So we need to account for those. And let's look at the structure for each one of these pieces of data. So it looks like this whole structure here is in a table. Each row is 2 pairs of the data. Each TD is one of the pieces of data. And inside there's the A-ling for the name, the scientific name. Then there's a div, and then there's another div that has the image. And then there's these rows, these other divs that have the content. So, you really have to go off based on how this website's constructed, right? And so it's constructed, what do we have to hook into it? And so it looks like every piece of information here has a div, and then it has an ID associated with it, right? So there's a class called row, but there, it doesn't differentiate between what's in that row. But it looks like these IDs are pretty unique. So let's copy a couple of them and put them in our script to see what they look like. So there's one. Let's pull one. Let's pull the one on the other side. There's another one. Let's pick one from down here. And let's pick its counterpart. So now we have a kind of a sampling of what they're using to name these IDs tags. And so if we look here, we can see that, so it says these are all the same, and then it gets to this place here where it says it's either on the left or right, it looks like. And then this number looks like it's like the row that it's on. So starting with 0, and then it has like a common name row, and then another 0. So let's look at the fields for another one. Let's look at the one for the type. And add that into the mix for the same one. So this looks like it changes for the different type it is, but these numbers appear to be like the row that it's happening on, right? Let's look at this zone one on this side. And that's it's on the 6th row. So the numbers repeat at the end. This changes if it's left or right. And then this is the name of the row that they gave it. So this is actually kind of a weird web page as far as how they name stuff. Usually they don't give every single element its own ID. It kind of defeats the purpose of IDs. But in our case, it's nice that they did that because now we have basically an address for every piece of data on the page that we want to use. Each one of these divs has its own ID, and if we just reconstruct what type of, its position and its row number, then we could recreate this ID for each one of these pieces of data. So we just need to check to see, okay, so this starts at, like we said, 0, and it goes down to the last one, which would be this one, which is 11. So 11 rows, or, starting at 0, so there's 12 rows, which makes sense because there's 24 per page, right? All right, so what we can do is we want to build a loop then. We want to build a loop that loops 11 times, or 12 times, from 0 to 11. And then we want to, inside of each one of those, build the IDs for each one of these left and right pieces. And keep in mind, sometimes they won't exist, right? So the synonym works is over here, the names are over here, but there's not an equivalent one on this side. So we actually have to test to see if it exists and all that stuff using Beautiful Soup. All right, so let's just get all the names of all the fields that we're going to use just so we have them as a reference. So that's one of them. And so this one can be either the left or right, and then this is the row. We'll say, row. This is left or right. This is just like placeholders here. So that's the one of them. That's a common name. Next one is the type. Um, so the only thing that changes here is the type. I'll space this a few more times because we're going to do it a couple more times. And then we have the zone. So it's a zone row. Then we have the height. It's called height row. Then we have synonyms, which are inside a row called synonym row. All right, so these are the main pieces, right? So we could actually be pretty fancy with this. We could even maybe turn this into a loop as well. So let's start with the first part. We need to be able to loop 11 times. So we'll say for row in range, and we'll say start at 0 and go to 11, but so we need to say 12 because it will stop at 12 and not do a loop for that one. And then for each one of those, we know there's going to be one on the left and the right hand side. So we could say for left or right in, and we can actually make our own little list here, left, right. So it would loop twice, right? It would do the left one and then the right one. And this would be left the first time and right the second time. And then inside of that one, we need to go through each one of these rows, right? So we could say for field in, and we can make a little list for this one too. Common row, type row, zone row, height row, and then name row. So for each one of these loops, it would be one of these, right? So we can comment this out, or actually this is going to be our string here. So we'll make a new string called ID, or we'll say use ID, and we'll set that to a template string. And we're going to plug in these variables that we just defined, right? So row is going to be replacing this one, and left or right is going to be replacing this one. And then we actually have to add one here, so we'll add field type. And so that's this one, field. So we're building all these IDs dynamically. Let's just print them out and see, uncomment this HTML print. Let's run this and see if we are producing a bunch of IDs that look valid. Right, so you should potentially be able to, let me cancel, potentially be able to pick one of these, like this one, or this one. Not all of them have synonyms, so if we say, we're not going to do this in JavaScript. I'm just using JavaScript to see if this ID works as a way of identifying one of them, right? So it does, right? So there it is down here somewhere. All right, so what we need to do is we now are building a ID for each piece of data on the page, which is pretty wild. But we can use Beautiful Soup now that we parse it to pull out that ID value or that element and get the contents of it. And so we can do that by saying, let's make this, we'll call this element, and we'll say soup dot find. We're only going to find one of them, and this is a div. These are all divs, I believe. These are all divs. Oh, I guess we didn't do this one, right? Search, collection, control, right, taxon, name. So this is actually not a div. This is um, a link here. So we'll have to do something special for this one, special case. But let's do the other ones we were working on anyway. These ones below here. All right, so we'll find the div where the ID is going to be equal to the ID we just created. And so if we run this, we should see a bunch of IDs, and occasionally we'll probably see one that says none because the synonym one does not exist, right? So These are all the divs for the different ones. And we're not getting any errors, like it's not breaking either, so that's a good sign. So it looks pretty good. Um, there's a none, right? So we can see that sometimes it shows up. All right, so we're pulling out this data, and so now we need to store it somewhere. And so we can think about how we're going to structure this data, right? So each one of these plants here is one of the items in our data set that we want to keep track of, right? So we can make a new item, we call it data, a new data for each the row, right? But then we'd want to make it one for each one on the left and right as well. So we need to move this here. So we're creating a new data blank dictionary for each row and then each left or right, right? And so what we need to do now is just we have the field name that we're using and we have the element if we found it, and all we need to do now is just to check to make sure that it exists. So in Beautiful Soup, if it equals none, then it doesn't exist, right? So it wasn't found. Otherwise, it's there, right? We found it. So what we could do is we can now build out our data dictionary by inserting the field name. So this is whatever field name we are in this loop, and set it to the value of the element, right? And so we don't want just to set it to the value. We actually want to pull out the text of the value. And so to do that, we do this built-in method called getText, I believe. And so that will take the contents of the div and store and return just the contents, right? So it would return this piece here. And it looks like there's like some leading spaces sometimes and trailing spaces. I don't know if that would be picked up, but let's just be careful here, and we'll just strip out any white space. So this will return the string, and then this will act on the string and strip out any white space. So at the end of this, we should have built out this empty data dictionary with each one of these rows if they exist, right? So let's just print this out and see if it worked. All right, so now we have a dictionary for each one, and we can see it's growing for because we're printing it on each loop. We can move this printout towards, we can unindent this probably if we wanted to test it. So we don't see each field being added, we'll just see the end results. And we just want to make sure that it's working, right? So here's one that looks pretty populated. Here's the common name. So it has these labels included. You can clean that up later, right? Zone, height, synonym, etc., right? And this is interesting too. Like this, if you look at the synonym field, it's actually quite a number of fields, right? There's like a bold, then there's a break, then there's some italic fields, and there's no fields, and then there's with messed up Unicode characters. It's not good. And then a bunch of other fields. So that get text command actually just gets all the text within the parent within this div. So all these things are kind of parsed to text and returned. So it returns the whole thing, which is nice. We don't have to go through each element and try to figure it out. So of course, you'd want to clean this up. Maybe find and replace the height, parse these out into numbers and ranges, but we won't do that in this video. All right, so the other thing we wanted to do though is we want to pull out the scientific name and probably the link, right, to where to find this. And so this is a slightly different pattern, right? This is what it looks like. It's the same kind of style, but it's not a div, so we can't use the same loop that we were using here because it's not. We're looking for a div. So we could do this in two different ways, but we could make this more complicated. But let's just make a separate process for it here. We'll just do it one off here, and we'll say we'll build a new ID here, and we will populate the piece that it is called taxon HTML name and change that. We'll just hard code that. instead of the variable that we had. And so the rest of it still works, right, left and right, and the row number is still the same, but we're building this URL, this ID separately for just the A-link. And then we can use the same code pretty much, but we'll change it for A-links instead of div links. And then we should be able to see this element. So let's print this out, see if it's working. You could potentially, to be very safe, test this, right, and say, I want to make sure it's not equal to none. But if the plant name is missing, then that's probably a pretty big problem. Um, so we're just going to assume it's there. And if you ran into some error later on, it's pretty easy to add that. So let's do the same thing here. Let's print out the get text in the strip and run it again. And we can see we're getting all the nice names of the different plants. Um, okay, so now we have that piece. We can also add that to our dictionary by saying data, and we can say something like taxon name or something like that equals the result of that. The other thing we probably want to keep track of, though, is this the URL to the plant page itself. And this is interesting. This is where the site differs in its way it works, right? So we're on one path here. We were on Plant Finder, and now there's Plant Finder details, and you can see um, it's now passing parameters in the URL like a traditional site. So it could be potentially that we don't actually have to use Chromium if we wanted to pull out this page as well. It would kind of just work. So it looks like there's like a taxon ID, and if you open that in a new tab, it just loads that page directly, right? There's no weirdo sort of cookie session stuff going on. It just passes this number and it works, right? So if we looked at this one, we could find its taxon number and put that in there in this existing URL, and it would just work, right? So we can do that. So what we need is the taxon number or the URL to that, so we could maybe scrape that later. So what we need to do is figure out how to get the A elements attribute, right? Because this is in an A element and it has the href as the value. Um, and so in Beautiful Soup, how do we do that? Let's see. In Beautiful Soup, you need to, I'm not sure. Let's look it up. So I'm just going to search how to access an attribute value in Beautiful Soup. Get attribute. Um, so they say you treat it like a dictionary. So in this case, that's their A link, and then this would be the href, right? So if we do that, we can say data plant link, and we'll say this is our element, and we'll just treat it like a dictionary to get the attribute. And then let's just print out this at the end and see if this works. All right, so it looks like it's working. The problem here is that the plant link is a relative URL, right? It doesn't have the HTTP blah blah blah.com, so it's missing everything before the plant finder. It's not there. So just to be nice to our next script, we could add that in there, right? So we could just copy that and hard code it in our script. So we could say uh, add this piece to it before you add that end part to it. And this one starts with a slash, so we don't want to end in a slash. We'll just leave it like that. So if we run this again, we should see full URLs being built here, right? And we could go to one of these and see if it works. Painted Beauty. Yeah, there it is. Okay, so let's see if there's anything else we want to do. I mean, we're just interested really in the data, but you could also do that for the image the same way we did the A link. but we'll skip that for now. So next step is all we need to do is compile all these pieces of data. Um, and so we need to make a new variable somewhere. We'll call it all data. I'll make it a list. And then after we're done doing this, where we were printing it out, let's delete this comment. We'll say all data append, and we'll just add the data that we just built up, our dictionary. And then of course at the end we'll say JSON. I don't think we've imported JSON yet, so we'll go ahead and import that. And at the end we'll say JSON dot, we'll use the dump, and we'll say dump the data, sorry, all data to this new file. We'll call it all data.json. Open it for write mode, and we'll just indent it just so it's nice. So we could give this, this is running locally, so it's pretty fast, but we can still add a little status so we know where it's at in the script. I'm just going to print the file name as it runs through them. So it's interesting, right? This is, even though it's running locally on, the file's local, everything's local, it still takes a few moments to parse the HTML and pull out the data. So we'll let this run. All right, so of course it got to something and it ended here. It broke a certain place. On line 40, it says type error, non-type error, not subscriptable. So if we go to our line 40, that's where we're pulling out the URL, the href. So it looks like there is a plant at some point that doesn't have a title, right? And so we can kind of debug this. This says this happened on 285, file 285, which also happens to be the last file. Very suspicious. But if we look in here, we could try to see um, what's going on here. Hmm. So this looks like it's a not not very similar to the other files. Okay, so this was the last HTML it downloaded, right? So I told you it earlier it broke, right? So it looks like the 285 is actually was an error, right? So this was the web page that was returned because the server didn't send something, and then it saved the HTML of this page with the little frowny face guy and everything. So that's what this one. You can kind of see, if you can see it's a little small, but the file size is much larger than the rest of them. It's like 100 kilobytes bigger. So we know that that one, it doesn't contain any data. We can delete it, and we'd rerun the previous script to pull the down data and make sure we get that one populated. So that was just kind of like not a problem with our scraping text or scraping code. It's just a problem with um, the data itself that wasn't downloaded. All right, so we'll run this again and not get an error this time. All right, so I finished running. We should see in the same directory, right? Here's our extracted all data there, 2.4 megabytes. It's not tiny. So let's take a look at it. And so now we have a dictionary for each plant that we have, and then in each one of these, as I said earlier, you'd want to clean up some of this stuff, remove these labels that are in the actual string. But we also have this URL to the full plant. And so you could have another script, right, that opens this file, loops through this JSON file, and loads each one of these URLs, and that would give you access to all the more data in here, right, that you might want to get access to. So we're not going to do that part, but you can kind of imagine that would be more of a traditional, because we already we kind of proved that you don't need Chromium and Selenium to do that part, right? Because the URL includes the link to the ID and it responds, the same way that it would. If it didn't, if you try to do a request on it and for some reason it wasn't sending back the data, then you could apply the same methodology of using chromedriver and Selenium to do that, but it would probably work just using straight requests and Beautiful Soup. But so that's it. We have the data, and we can continue on building it out using that next script. So some quick takeaways. If you're working with a site that is basically not compatible with just doing straight vanilla requests to it via Python and parsing that with Beautiful Soup, you can switch out that request part with this Chrome driver and Selenium module here. And so that it really treats you can, in the bare minimum, you can use it just to get access to the HTML for a certain page. And this is also true for if a website is using a lot of JavaScript, and after the page loads there's a lot of dynamic activity, and the page populates a lot of data. If you're not able to get access to that data and it's only available in the HTML after it's been rendered, then you could potentially use this also for that situation where there's a lot of JavaScript activity, and you just want the HTML that the JavaScript creates, not what the server is sending. So there's really a lot of use cases where this approach would be useful. Um, as we saw, we did some pretty fancy JavaScript commands to get what we wanted to do, but at the bare minimum, you could just use the Selenium and Chrome driver to just get the HTML of a page loaded in a browser. And there's much simpler ways of doing things as far as how the site works. It just so happens that the site we were working with was fairly complicated. And also, hopefully, if you do this for another site or you do this for a project, it's always good to think of ways to create a script that's recoverable. And so in this case, we did it by just saving the HTML out by itself and then checking to see if that HTML file exists. And if it exists, means that we've already done that one. So skip this one and go on to the next. So as I said, this is a really good methodology for working with difficult sites that to scrape. And I wouldn't say that this was this for this particular site. It wasn't like they intended this to be difficult to scrape. It's just that the technology that they used works in a certain way that's not compatible with trying to web scrape it. So it wasn't like it's trying to do that on purpose. It's just the nature of how this particular web server works, and that was pretty much kind of just limited to how we interact with it. So lots of ways to interact with websites using the Selenium and Chrome driver methodology, and it's a really great kind of tool for scraping these sites. So that's it. I will talk to you later. Bye.